So the root removal project, funded by the USDA CARE program, as well as the Northwest Center for Small Fruits, was developed when researchers made the observation that in a replant situation, large amounts of raspberry root and crown material remain in the field. Now, knowing a little bit about the pathogens that affect red raspberry, we realized that this material that's left in the ground could serve as a reservoir or a source of inoculum that could reduce the efficacy of fumigation and lead to increased populations of soil-borne pathogens in the next planting of that crop. So the main question that we were trying to ask with the root removal project was, if we remove root and crown material prior to fumigation in a replant situation, would this improve soil-borne disease management in red raspberry? The short-term goal of the root removal project was to evaluate and demonstrate the efficacy of raspberry root inoculum removal as a pre-plant management technique for reducing soil-borne pathogens in a replant situation. The project plays into the overall team's goal as well, which is to develop practical and effective tools for the integrated pest management of soil-borne diseases. In this project, we compared 3 root removal devices: a Lundeby plant lifter, which was locally available, a potato digger, which was also locally available in the Whatcom County area due to the seed potato industry, as well as a beach cleaner, which isn't locally available, but one of our local growers was excited about the idea of root and crown removal as a potential tool to improve soil-borne disease management in his field and purchased one on his own accord, which we utilized for our experiments. From that experiment, what we learned is that the Lundeby plant lifter, although slowest in terms of removing root and crown material, was also the most effective, whereas the potato digger was the fastest but least effective. Additionally, we established field experiments in 2 grower cooperating sites. In one experiment, established in 2014, we compared root removal with fumigation and without fumigation. This project demonstrated that root removal is not an effective technique for improving soil-borne disease management, at least for root lesion nematode. We're still looking and learning about how root removal affects Phytophthora rubi in a replant situation. What we learned from our first experiment, though, is that root lesion nematode populations return to pre-plant levels in all treatments within 1 year after fumigation, and there was no treatment effect. Additionally, what we learned was that Pythium and Fusarium populations, which were used as a proxy for Phytophthora rubi at that site because Phytophthora rubi or Phytophthora root rot was not present, was at pre-plant or pre-fumigation levels by planting of the following year. However, we did see a slight benefit of our fumigated treatments in terms of plant growth and first-year yields in 2015, even though populations of the key soil-borne diseases that we were monitoring were statistically the same across all treatments. This is very interesting from a research perspective because it suggests that there are other factors contributing to replant disease in red raspberry, which we are exploring utilizing molecular tools in another project. The importance of this is that if we are better able to understand and characterize replant disease and the organisms involved, we may perhaps be better able to develop tools for effective management. So our research team is composed of Washington State University researchers, extension educators, as well as USDA research pathologists located in Corvallis. In addition, we work with private researchers such as Walters Ag Research. One of the major benefits of our research is that we work very closely with commercial growers in Whatcom County and conduct most of our research on commercial farms. This gives us a great benefit in terms of being able to apply treatments in a commercial setting and see how they manifest.